We're going to use our previous work with the log functions to describe transformations of the graph of f that yields the graph of g. If f is the log base 2 of x and g is now log base 2 of x plus 3, think of our transformations. 3 is with the x. We would just take log base 2 of x and shift it left 3. For the next example, if we have a log function with base 10, and then we transform it by the equation -4 minus log 10 base x, we see two changes that are occurring. We see the -4, which is a shift down, and we see the minus in front of the log function. That's a reflection. We might want to start with that first. The negative is going to reflect, and we're going to state through which axes. That's going to be a reflection through the x-axis. So think about flipping the log graph horizontally through the x-axis. And the -4 is not with the x, so it's a shift up or down, and in this case we're going to shift the graph of log base 10 down 4. So part of your work is going to be with problems such as this, where you just have to describe the transformations. Okay, let's study f and g. F is the log function base 6. The changes over here. 5 is with the x, so we're going to shift log base 6 of x left 5. The 2 is a shift up 2. All right, let's get down to some other problems where we're going to actually sketch the graph and not just describe the transformations. So for these three right here, we're going to start out with a log function. We're going to notice some changes to that parent function. We're going to graph it, and then we're going to state the domain and vertical asymptote. For me, I probably would graph it first and then use my graph to fill in the domain and vertical asymptote questions. All right, so coming over here, I know that it's log base 2 shifted to the right 3, but what I'm going to do is I'm going to draw log base 2, the parent function. At this point, hopefully we know what a log function looks like. Log base 2 of x is going to pass through 1, 0. That's going to be kind of used as our, this point is going to be kind of used as our significant point to transform log base 2 of x minus 3. All right, so I'm graphing log base 2 of x, the parent function. Looks something like this. The only transformation, and you might want to record that over here for yourself, is to move that parent function right 3. So let me go in a different color. All right, so if we have this point 1, 0, let's move this point 3 to the right, and then we can draw the graph of the function off of that. So 1, 2, 3. So right 1, right 2, right 3. So this point is now 4, 0. And let's draw that function off of this point. Okay, continuing down this way. Be very careful about how you draw the rest of this graph right here, because you might notice that there is a vertical asymptote right now at x equals 3. Okay, so let's come over here and record the domain. Okay, well the domain now for this function isn't 0 to infinity as the parent function is. The domain, okay, is going to begin right after 3, so the shift right 3 moved our domain, moved all our x's to the right 3, and our vertical asymptote is now x equals 3. Okay, so for the remaining two problems, we're going to graph the parent function and then the new function, and we're going to fill in the domain and vertical asymptote. All right, studying the transformations, let's go ahead and make a recording. We're going to reflect through the x-axis. And also we're going to shift the graph of log base 5 up 1. So I'm going to go ahead and do the graph and then fill this information in a minute. All right, the parent function I'm going to graph of log base 5 x passes through 1, 0. Okay, and we notice that x equals 0 is the vertical asymptote for that parent function. All right, based on these changes right here, we're going to reflect through the x-axis and move up 1. I might actually take 2 steps to do both of these. So reflecting through the x-axis in red, this part of the parent function goes into quadrant 1. That's just the reflection piece. Okay, now in my final color of blue, we're going to move the graph up 1. So shift up the point 1, 0 to 1, 1. Off this point, draw a graph similar to what's in red. Yep. You can always go to your calculator and confirm. Go to Y1, type this in. To locate this on your calculator, you would hit Alpha Window Option 5. That's Alpha Window Option 5. So my blue graph is my final graph of F. All right, let's come over here and report the domain. Well, the domain of my final graph in blue, my domain is 0 to infinity. And the vertical asymptote is still x equals 0. So I can shift up and down or reflect, and I'm not going to change the vertical asymptote. Or the domain for that matter. Okay, let's look at our third and final example. All right, based on the parent function log base 2, 1 is with the x, so we're going to move log base 2 of x left 1 and up 4. Parent function. We'll work off this significant point of 1, 0. We'll move that point left 1 and up 4. I'll go to blue. So left 1 and up 4. Shift left, up. Okay, that important point is now on the y-axis. Okay, coming back and looking at how we would draw this function off of this point, it would look something like this. Okay, notice when you draw to the left, you don't want it just to extend outward. Okay, you'll never go further than 1 over to the left. Let me draw it extended down a little bit. You might want to go ahead and draw in a vertical asymptote at x equals -1. There we go. All right. So what's the domain? Well, the domain is going to be -1 to infinity. So the shift left and right is going to change your domain. And the vertical asymptote is the x value of the beginning point of your domain, -1. All right, so that's it. Describing and graphing logarithmic functions with transformations.